Alright, so today we're doing trigonometry, and to start off with, it's just going to be a really quick review of stuff that is just assumed that you already know. So the three ratios that we start off with, I'm not even going to draw the right angle triangle. I'm just going to assume that you know what these ratios are and that they're all to do with a right angle triangle at this stage of our lives. So it's sine of theta is equal to the opposite over the hypotenuse. Hey guys, shouldn't be any chatter, just writing now, thanks. The cos of theta is the adjacent over the hypotenuse, and the tan of theta is equal to the opposite over the adjacent. Alright, so there are our three things that we're starting off with. Now the thing that we also looked at last year as we worked through trigonometry is that we can invert each one of these ratios, which gives us a new sounding kind of a ratio. The first one is cosec. Cosec theta is just what the sine ratio was, but it's inverted. Okay, so we'll have hypotenuse over opposite. We'll have sec theta, which is the hypotenuse over the adjacent. And we'll have cot theta, which is the adjacent over the opposite. And at the beginning, I found it difficult to remember which one of these additional three ratios goes with which one of these. And then I figured there's a little bit of a pattern there. The third letter of this always matches up with the first letter of its corresponding ratio. Alright, so the third letter of cosec matches up with sine. The third letter of secant, or sec, matches up with cos, and the third letter of cot matches up with tan. So the actual names of these ratios are cosecant, secant, cotangent. Alrighty? They're things that are, that's revision. That's a review of what we've been doing so far.
We didn't do that.
Oh yeah, we did.
No, we didn't.
Yeah, we did. Then,
literally everyone is saying we didn't.
yes, that's good. Everyone's forgotten. Oh my God.
Mr. Grant, someone will remember if we did it.
Oh, do you think?
Someone.
Oh, it's rebellion. So now you're going to tell me you don't remember anything about complementary angles, is that right?
What are they?
Yeah, that's what I don't remember. What are they? All right. There is what we established was when we're looking at a right angle triangle, what we found out is that the sine of an angle, theta, is actually equal to the cosine of 90 minus whatever that angle was. Great. You know, and we could just do a really quick little example over the side here. If we've got 30 degrees in there, we know that sine of 30 degrees is 1 over 2, and the adjacent side would have been root 3. So sine of 30 degrees would be 1 over 2. If I do cosine of 60 degrees, which is 90 minus 30 degrees, cosine of 60 degrees is 1 over 2. So the sine of an angle is equal to, let's just do that little example, e.g. sine of theta, of 30 is equal to the cosine of 60. Alright, from that little example, you can see that, okay? The corresponding relationship is cosine of theta equals sine of 90 minus theta. Secant of theta is equal to the cosecant of 90 minus theta. And the corresponding relationship is cosecant of theta is equal to the secant of 90 minus theta. Now here's where it's a little bit different. The tangent, tan, of theta is equal to the cotangent, cot, of 90 minus theta. And cot of theta is equal to tangent of 90 minus theta. So the last two relationships are a little bit different in that it's about when you invert the ratio, you get tan of theta will be the same as 90 minus theta. Now at that point there, that's enough to get us started with exercise 6.1.